Dear viewers, a warm welcome to all. Today, our topic is an overview of medicines from a chemist's perspective. We know that chemistry is a branch of science that supports us in every walk of human life. Now, chemistry in medicine. One of the remarkable applications of chemistry is in the field of medicine and healthcare. We know that medicines are the great boon from chemistry because medicines are chemicals. Now, medicinal chemistry. Medicinal chemistry is a discipline that encloses the design, development and synthesis of pharmaceutical drugs. This branch combines expertise from pharmacology, chemistry and other biological sciences. Regarding drugs and medicines, these two terms need some clarification. We know that drugs are chemicals. Then how drugs differ from medicines? Drugs are chemicals which are able to produce a biological response. But when that biological response is therapeutically useful, that drugs are termed as medicines. That's the difference between drugs and medicine. More clearly, we can add some more difference between drugs and medicines. Medicines are used to cure disease, whereas drugs may or may not cure disease. Medicines are safe for animal body. However, drugs may be harmful. Insignificant minimal side effect is provided from medicine. However, drug may lead to severe side effects. Medicines generally will not lead to addiction. However, drugs may lead to addiction behavior. Now, drugs. The drugs all are chemicals in nature. They may be organic or inorganic compounds, and that drugs may be of natural origin or that may be synthesized in the laboratory. Several drugs are isolated from natural sources like plants, animals or fungi, and some other drugs that we are synthesized by synthetic methods in laboratory. Now, medicines. The medicines are mainly used to cure, prevent or treat a discomfort situation. The medicines must be effective, it ensures safety and it should ensure minimal side effect on animal or human body. Now, on a broad scale, the drugs can be classified into two categories. They are over-the-counter drugs or OTC drugs and prescription drugs. The OTC drugs that we can directly purchase from a medical shop or a laboratory without the prescription, they belongs to the category of OTC. However, there are some medicines that we cannot directly purchase from a medical shop or from a laboratory that need prescription from a medical practitioner. Such category of drugs are termed as the prescription drugs. Now, one interesting thing, have you ever noticed the presence of the notation RX in a doctor's prescription sheet? What this RX represents? Simply, for instance, a doctor's letter tab represents tablet, and in every medical prescription we can see this notation RX. This RX is representing that it is a shorthand representation. That means prescription. But actually, the term RX is a contraction of the Latin word recipere. That is, RX came from Latin word recipere. That means take. That is, the patient has to take that medicine. That is the information from this word RX. Now, we can move on to different category of drugs. There are several categories of drugs like antipyretics, antibiotics, antiviral drugs, febrifuges, different category. Now let us have an overlook on different category of drugs that we use in our daily life. First of all, we are dealing with antipyretics. Pyretic means temperature. Antipyretic means a medicine or a drug that is used to reduce the temperature, used against temperature. That is, antipyretics are class of medicines used to reduce the body temperature, animal body temperature. Some common examples are cited here: aspirin or acetyl salicylic acid, paracetamol, that's a very common antipyretic, that is nothing but 4-acetamidophenol, and phenacetin, that is 4-ethoxyacetanilide. Regarding the first antipyretic, that is aspirin, it is acetyl salicylic acid. This is the chemical structure of acetyl salicylic acid. Salicylic acid contain on OH group and a COH group. Whenever we are acetylating that OH group by introducing a COCH3 group, we will get acetyl derivative of the salicylic acid. That acetyl derivative of salicylic acid is taken as aspirin. It is a very powerful body temperature reliever. It can also use it to reduce pain, fever or inflammation. Regarding the chemical synthesis of aspirin, aspirin can be prepared by the direct acetylation reaction of salicylic acid. For this acetylation reaction, we are using acetic anhydride as the acetylating agent. Instead of this acetic anhydride, we can also perform acetylation by using acetyl chloride or any other acetyl introducing groups. For instance, this one is the salicylic acid molecule. Whenever we are reacting it with acetyl chloride, that is CH3COCl, this chlorine and this hydrogen eliminate as HCl molecule, and acetylation performs, we will get OCOCH3 group here, COH group here. This is acetyl derivative of salicylic acid, and this molecule is aspirin. This is another method of preparation of aspirin. Instead of this CH3COCl, we can also use acetic anhydride, CH3C double bond O, oxygen, C double bond O, CH3. This is another important acetylating agent. So by using any acetylating agent like acetyl chloride or acetic anhydride, you can perform the acetylation of salicylic acid to produce aspirin. Now, the second antipyretic drug. The second antipyretic drug, and this one is the most popular antipyretic drug, that is our paracetamol. Paracetamol is actually 4-acetamidophenol. This is the fourth position. In the fourth position, there is an NHCOCH3 group. Fourth position from phenol, there is an NHCOCH3 group. That group is called acetamido group. This compound, para-acetamidophenol or 4-acetamidophenol, is otherwise called acetaminophen. It is its chemical name. This paracetamol is used to treat headache, muscle ache, arthritis, backache, toothache, cold and fever. So this means in addition to the antipyretic activity, this paracetamol molecule is also able to reduce the body ache or body pain. Regarding the preparation of paracetamol, paracetamol molecule can also be prepared by a direct acetylation reaction that I already mentioned in the case of aspirin preparation. Here the starting compound is para-aminophenol, that is, in the fourth position of the phenol molecule, there is an NH2 group. This is 4-aminophenol or para-aminophenol. This para-aminophenol molecule, on reaction with acetic anhydride, produces 4-acetaminophenol or our paracetamol. One important parameter associated with the paracetamol dosage is associated with the paracetamol dosage. Now, the recommended dose of paracetamol. Continuous usage of paracetamol molecule is not recommended. It will lead to several side effects. Then what will be the recommended dose of the paracetamol molecule? For adults, 500 to 1000 milligram every 4 to 6 hours within a maximum of 4000 milligram per 24 hours. That is, a healthy adult has a maximum dosage of 4000 milligram, above which it will lead to several adverse effects on human body. The last antipyretic drug, that is phenacetin. Phenacetin is chemically 4-ethoxyacetanilide. It was a very popular pain reliever as well as a febrifuge or antipyretic. However, after 1970s, the medicine is partially withdrawn from the medicine field because of several side effects and toxic effects on animal body. This is the chemical structure of phenacetin. Now, moving on to another category of drugs, that is antacids. We all heard about gas trouble, acidity and associated disorders. That's the most popular thing, the disorder as acidity problem. In order to relieve from the acidity problem, we are using a category of medicine called antacids. Why acidity arises in our stomach? This is due to the overproduction of acid in our body. Overproduction of hydrochloric acid is responsible for acidity in the body. The usage of antacid remove excess of acid and raise the pH up to appropriate level. We know that during acidic production in our stomach, pH reduces below a certain level. That is not a favorable level. So, whenever we are using antacids, that antacids neutralize excess acid present in our stomach and raise the pH up to desired level. Now, the excess production of hydrochloric acid in the stomach may lead to some difficult situations such as acid reflux, heartburn, etc. This is exclusively due to the presence of hydrochloric acid. How this hydrochloric acid mainly produced in our stomach, obtained in our stomach? This is mainly due to some stress as well as due to the usage of spicy foods. Several antacids are there. Some important antacids are magnesium hydroxide, magnesium carbonate, gelatinous form of aluminum hydroxide or sodium bicarbonate. All these are good examples for antacids. You are familiar with the common medicine Gelusil antacid, and that is a mixture of magnesium hydroxide with syrupy form of aluminum hydroxide. Now, omeprazole. Omeprazole is a very popular antacid medicine, and this is the chemical structure of omeprazole molecule. Usually, we are taking this omeprazole molecule just half an hour before our food. Moving on to another category of medicines, that is antihistamines. We all heard about allergy problem or allergic disturbances. These antihistamines are otherwise called anti-allergic drugs. Anti-allergic drugs are a category of medicine used to treat allergy. Several examples are reported. Most popular examples are cited here: cetirizine, diphenylhydramine, chlorpheniramine and promethazine are good examples for anti-allergic drugs. Moving on to the details of these drugs, first of all, we can take cetirizine. This is a very popular medicine that appears as very small tablets, and this cetirizine medicine is used to relieve allergy symptoms such as watery eyes, running nose, itching of eyes or nose, sneezing, itching, etc. It works by blocking the central natural substance, that is histamine, certain natural substance, that is histamine. This histamines, when the histamines are produced, whenever we are suffering from some allergic reaction, our body produces histamine. That histamine causes several allergic outcomes. So, these antihistamines medicines like cetirizine prevent the excess production of histamines, and hence they are otherwise known as antihistamine drugs. This is the chemical structure of cetirizine molecule. There are several side effects associated with cetirizine, and some important side effects are sleepiness, dry mouth, headache, and abdominal pain or stomach pain. This about cetirizine. Now, another category of medicine, that is analgesics. Analgesics are very important medicines. Suppose our body, there will be a wound, or there will be some tumor or some associated pain. We have to relieve that pain. There are so many medicines in science used to relieve that body pain or body ache. Such category of drugs are termed as analgesics. The word analgesic is derived from two Greek terms. First one, an, that means without, and second Greek word algos, that means pain. So analgesics are a category of drugs used to relieve pain. Analgesics, also known as painkillers, relieve different types of pain, from headache to injuries to arthritis, etc. Now, there are two important categories of analgesics. That is, on a broad scale, we can classify analgesics into two types. They are narcotic analgesics and non-narcotic analgesics. Then what are narcotic analgesics? We can enter into great details of that narcotic drugs. That narcotic drugs generally causes some addiction behavior. However, non-narcotic drugs will not create addiction behavior. They are therapeutically more useful. But comparing the effectiveness of narcotic drugs and non-narcotic drugs, narcotic drugs are better performers, even though they are leading to several side effects. For instance, suppose a patient suffering from serious cancer pain, then we are using, the doctors recommends usage of narcotics like morphine. For instance, morphine as morphine sulfate is an excellent medicine that we are given to cure the serious pain for cancer patients. Several narcotic drugs are there. They are generally morphine or their derivatives. Morphine derivative codeine and heroin are excellent examples for narcotic drugs or narcotic analgesics. Now, non-narcotics, aspirin, Novalgin, ibuprofen or simply brufen, naproxen, diclofenac sodium are nice examples for non-narcotic analgesics that is in common use. Regarding narcotics, more details about the narcotics. The narcotics in general are opioid drugs. Opioid drug means that drugs isolated from plant, opium plant. They relieve pain by binding to opioid receptors. In our body, there are several opioid receptors. They are chemically opioid receptors. They are chemically important molecules that are responsible for pain, that is related to central nervous system. And these narcotic analgesics act upon opioid receptors present, and they are mainly present in central nervous system as well as peripheral nervous system. And this narcotic drug has connection with opioid receptors. The opioid receptors or narcotic analgesics broadly divided into three types based on their availability. First of all, natural narcotics, semi-synthetic narcotics or synthetic narcotics. We can move into details of that. Some natural narcotics are morphine, codeine and papaverine. Semi-synthetic derivatives are heroin, benzyl morphine. Synthetic derivatives are pethidine, methadone, etc. Now, the first narcotic analgesic ever known, that is morphine. As I mentioned earlier, morphine is a medicine that is mainly given to patients suffering from cancer, and this morphine is given to patients as morphine sulfate by either through injection or in the form of tablet. And this morphine is isolated from this plant. That plant is nothing but poppy or biologically, botanically, it is Papaver somniferum. And this morphine isolated from Papaver somniferum is a very important narcotic analgesic. There are several disadvantages. Even though highly effective in curing the pain, this morphine has several disadvantages. Regarding the disadvantages, it may lead it to addiction, that is prolonged or continuous usage of morphine drug lead it to addiction behavior. Another one, the overdosage. Cancer patient, due to their severe pain, they may continuously take morphine drug as morphine sulfate. In that situation, that overdose may lead it to poisoning situation or overdose cause poisoning. And there are several side effects such as dryness of mouth, mental clouding, vomiting, fatigueness, etc. There are several disadvantages associated with the morphine drug. Next one, a semi-synthetic derivative of morphine, that is heroin. We all heard about heroin. Heroin not as medicine but as drug for drug abuse and related things. Exactly, heroin is a narcotic analgesic. It is a semi-synthetic derivative of morphine. Semi-synthetic derivative of morphine means the right picture represents morphine. In morphine, there are two OH groups present. If we are replacing that OH groups by acetate group, that is, if you are performing acetylation, diacetylation, we will get diacetyl morphine. Diacetyl morphine is chemically known as heroin, and this heroin has several disadvantages as well as advantages. Regarding the advantages, it is powerful medicine compared to morphine in relieving the body pain. However, this heroin is a drug. There are several reports on drug abuse associated with this heroin drug. Now, a totally synthetic narcotic drug, for instance, we are taking pethidine. This is the chemical structure of pethidine. Pethidine has another name. It is also known as merperidine. This pethidine or merperidine is used for the treatment of moderate as well as severe pain, or wide range of pain can be treated by this drug pethidine. Similar to heroin, pethidine is also widely used and it may lead to drug abuse. It is delivered as hydrochloride salt as a tablet or through an injection. Why it is used as a hydrochloride salt? From this structure, it is clear that there is a nitrogen, and this nitrogen is in tertiary form. Tertiary form means it is directly connected to 3 carbon atoms. Nitrogen containing compounds, this nitrogen with a lone pair of electron is basic in nature. So, that basic nature is neutralized by adding hydrogen chloride. As a result, this compound is converted to hydrochloride. Most of the basic drugs are taken as in the form of hydrochloride. That is why pethidine also taken as hydrochloride salt. Now, non-narcotic analgesics. Moving on to non-narcotic analgesics. These non-narcotic analgesics, as I already mentioned, they are less effective in curing the pain, but will not lead to addiction behavior. There are non-opioid analgesics, that is, such kind of non-narcotic analgesics are not obtained from opioid plant. They will not act on opioid receptors, etc. Some common examples are here: aspirin, Novalgin, ibuprofen or brufen, naproxen and diclofenac sodium. This diclofenac sodium is a very common medicine in our daily use. One representative example, brufen or ibuprofen. We are fascinated with its beautiful color of the tablet. Whenever we are suffering from some common pain, we are just to go to the medical shop and purchase 1 or 2 tablets of brufen. And this is a highly effective medicine curing in the pain, but not effective as morphine or other narcotic drugs. Brufen or ibuprofen belongs to non-steroidal anti-inflammatory drug category, that is NSAID category. NSAID category means non-steroidal anti-inflammatory drug category. It is used for treating pain, also for fever and inflammation. Now, another non-narcotic analgesic, that is naproxen. Picture represents the chemical form of naproxen. Here there is no nitrogen. It is not a basic compound. Naproxen is used to relieve pain from various conditions such as headache, muscle ache, tendonitis, dental pain and menstrual cramps. It also belongs to NSAID category as in the case of Brufen. Now, moving on to another category of drug, that is antiseptic. Antiseptics and disinfectants are two common category of drugs. What is the major difference between antiseptic and disinfectant? Before entering into that, first of all, we can focus on antiseptic. Antiseptic are used to kill or prevent the growth of microorganism. This antiseptic will not harm the living cells or living tissues. But I mentioned one term, that is disinfectant. Disinfectant has no selectivity. They are killing the host cell as well as the guest cell. That means they will kill the microorganism as well as harmful to host cells also. There are several examples for antiseptic. For instance, Dettol, that is a very common antiseptic. Tincture of iodine, iodoform or CHI3, then Salol or phenyl salicylate. These are popular examples for antiseptics. First one, Dettol. Dettol is a very popular antiseptic. That is a trade name also. Dettol is a mixture of two important organic compounds. These are the two compounds. First one, chloroxylenol, and the second one, alpha terpineol. Alpha terpineol is generally isolated from plant. Chloroxylenol can be prepared in the laboratory. These two compounds mixed in particular ratio with some additives, we will get Dettol. That is a very important antiseptic. Now another antiseptic, that is Salol. Salol is otherwise called phenyl salicylate. This Salol is marketed in form of Savalon. You are familiar with that compound, Savalon. Salol is a white solid. It occasionally used in sunscreen and as antiseptic property, and also having antiseptic property. That is, in sunscreen lotions, for the preparation of the sunscreen lotions also we are using Salol. Salol is another example for a very good antiseptic. Now, tincture of iodine. Tincture of iodine is prepared by mixing elemental iodine and potassium iodide or sodium iodide in ethanol and water. The chemical composition is usually from 2 to 7%. Tincture of iodine is a good common antiseptic. Disinfectants. What is the major difference between disinfectant and antiseptic? I simply mentioned antiseptic kill the microorganism completely without affecting the host cell. However, disinfectant has no selectivity. That means disinfectant can completely kill the microorganism. At the same time, they may kill the host cells also. Lysol is a good example for a disinfectant. For instance, Dettol is an antiseptic. Lysol is a disinfectant. Suppose in our body there is a wound. We will clean it by using Dettol and we are not using Lysol. But when we have to clean our floor, we have to use Lysol. No need for using Dettol. That is the difference between antiseptic and disinfectant. This Lysol is a very good disinfectant. There are some other examples also. 1% phenol, sulfur dioxide will belongs to the category of disinfectant. Major difference between disinfectant and antiseptic is consolidated here. Disinfectant are used to non-living objects to kill microorganisms, but antiseptics are generally used in living organisms because they will not harm living organism. Phenol is example, Dettol example for disinfectant, and Dettol is an example for antiseptic. The things we have already discussed. Another category of drugs, that is antibiotics. Anti means against, biotic means life. Antibiotics are some drugs. These are the substance produced by microorganisms. What are the microorganisms from which antibiotics are obtained? These microorganisms involve bacteria, fungus or molds, and the antibiotics produced from this microorganism can be used to kill or prevent the growth of other microorganisms. Such a category of drugs are called antibiotics. Now, the first antibiotic, penicillin, as we all aware, is the first antibiotic. The inventor, Alexander Fleming, observed that the killing of staphylococci by a fungus, Penicillium notatum. Later on, his studies on Penicillium notatum revealed the existence of a category of antibiotics known as penicillins in them. In 1928, at St. Mary's Hospital, London, he discovered the first antibiotic, penicillin. The research was performed in 1928. This is the museum in honoring the discovery of Alexander Fleming. This is situated in London, that is Fleming Museum. Now, a broad classification of antibiotics. As we classify analgesics into narcotics and non-narcotics, it is also possible to classify antibiotics into several types. There are two important categories, nothing but broad spectrum antibiotic and narrow spectrum antibiotic. Then what do you mean by the term spectrum? The spectrum means a range of microorganism. The range of microorganism that can be destroyed or killed by an antibiotic is known as the spectrum of that antibiotic. Some antibiotics are broad spectrum antibiotic. That means they can kill or harm or destroy wide range of microorganisms. That means they are effective against several kinds of bacteria. Several examples are there: tetracycline, ofloxacin and chloramphenicol are good examples for broad spectrum antibiotic. Amoxicillin, it is a very popular drug, that is a common drug also, that belongs to the category of broad spectrum antibiotic. Now, narrow spectrum antibiotics. This spectrum is narrow. That means these narrow spectrum antibiotics are only effective against a few kinds of, very few microorganisms, or it is effective for killing some microorganisms, some specific microorganisms. The penicillin that discovered by Alexander Fleming is a narrow spectrum antibiotic, especially for staphylococci infections. Moving on to the details of penicillin. A number of natural penicillin have been discovered. The first penicillin is isolated from Penicillium notatum, and there are several other structurally related penicillins are also invented. General structure of penicillin is shown here, and it should be noted that this R group is a variable group. By changing this R group, we can prepare several derivatives of penicillin. For example, penicillin G and penicillin V are two main category of penicillin in clinical use, still in clinical use, out of which penicillin G is termed as the benecyl penicillin. How we will get to this benecyl penicillin? This benecyl penicillin is obtained by replacing R group with a benecyl group. Replacing R group of the general penicillin structure with a benzyl group, we will get benzyl penicillin or penicillin G. In a similar way, penicillin V or phenoxymethyl penicillin is obtained by replacing R group of the general structure of penicillin with a phenoxymethyl group. This one represents the phenoxymethyl group. So, the common penicillins in clinical use are penicillin G and penicillin V. Penicillin G is nothing but phenyl penicillin and penicillin V is phenoxymethyl penicillin. There are so many penicillins can be practically prepared in the laboratory by replacing this R group with the different groups. But all such a penicillin will not have clinical applications. The two common clinically useful penicillins are mentioned here. That's all. Antibiotics will not work against viruses. It is a very important information. No use, suppose we are suffering from common cold or flu, no need to take antibiotic. Why? The reason is antibiotics will not work against viral disorders. So, we have to look or move on to different category of antiviral drugs that we will discuss later. Another important category of drug that we consider today is sulfa drugs. They are most widely used in chemotherapy. Chemotherapy is a branch of medicine. That branch is started by Paul Ehrlich. That is usage of chemicals for the treatment of bacteria diseases. Highly useful in the treatment of bacterial infection. Most of the sulfa drugs, there are enormous category of sulfa drugs, and these sulfa drugs are highly useful in curing bacterial infection. We can take details of the sulfa drugs. They are the derivatives of, structurally, chemically, they are the derivatives of sulfanilamide. This picture represents sulfanilamide. Sulfanilamide is the short name. The correct name is para-aminobenzene sulfonamide, and by derivatizing this para-aminosulfonamide or sulfanilamide, we will get several sulfa drugs. For instance, if you are replacing this NH2 group by a pyridine molecule, we will get sulfapyridine. Then by replacing this NH2 group with a guanidine molecule, we will get sulfa-guanidine, sulfa-thiazole, sulfa-diazine. So many examples are there. Different sulfa drugs have different activities also. For instance, we can take some examples now itself. Derivatives of sulfanilamide are generally known as the sulfa drugs. Some important sulfa drugs. First one, sulfapyridine. Sulfapyridine is the pyridine derivative of, sulfanilamide. Sulfanilamide on introduction of a pyridine molecule leads to the production of sulfapyridine. What is the use of sulfapyridine? Sulfapyridine offers cure against pneumonia, or even though this sulfapyridine is highly toxic, we have to compromise on its toxicity. That is a disadvantage. Even though it is toxic, sulfapyridine is highly effective in curing pneumonia. Another one, that is sulfa-thiazole. This thiazole molecule, thiazole means it's a heterocyclic compound. Heterocyclic compound means as a result of the ring structure, some heteroatoms like nitrogen, sulfur, oxygen, etc. are present. And this thiazole moiety is introduced into sulfanilamide. Then we will get the sulfa drug sulfa-thiazole. This sulfa-thiazole molecule is highly effective sulfa drug against cholera, dysentery and pneumonia also. In similar way, if we are replacing it with this thiazole molecule with another compound guanidine, we will get sulfa-guanidine. Sulfa-diazine. Diazine is another heterocyclic compound that contains 2 nitrogen. Instead of this thiazole moiety, if we are introducing a diazine, we will get sulfa diazine. In a similar way, we can prepare several derivatives of sulfanilamide, and all such derivatives, especially derivatives of sulfanilamide with heterocyclic compound, are known as sulfa drugs, excellent chemotherapeutic drugs. Some of them are toxic, we have to compromise on the toxicity also. Another category of drugs, they are tranquilizers. Where we are using tranquilizers? What is the need for using tranquilizer? Tranquilizers are medicines generally given to people suffering from mental agitation. They are used for the treatment of stress, mild and severe mental disease or mental problems. Our common inorganic molecule, lithium carbonate, is highly effective in preventing mental disorders. But that is not clinically useful. Several other kind of medicines are developed, and that all belongs to the category of tranquilizers. They can relieve stress, fatigue, etc. There are so many examples, and most common example are derivative of barbituric acid. Barbituric acid is an organic molecule. The derivative of barbituric acid are collectively known as barbiturates. Barbiturates like phenobarbital, etc. are good tranquilizers. We can move on to the details. Now, veronal, another one luminal, another one seconal. All these are good tranquilizers that given to pupils suffering from mental disorders or mental agitation. Moving on to barbiturates. Barbiturates, as I mentioned, are the derivatives of barbituric acid. The picture represents barbituric acid. It is a cyclic compound. Even though it contains no COOH group, it is having some acidic property. Hence, we call it as barbituric acid. It contains 2 nitrogen and 3 oxygen atoms in addition to carbon and hydrogen. Suppose we are modifying this barbituric acid by introducing some groups on this CH2 position. By introducing some groups, we will get derivatives of barbituric acid. So many derivatives are known, but they are collectively known under the name barbiturate, or a barbiturate is a drug that acts as central nervous system, and it is a central nervous system depressant. Another drug, luminal. Luminal is the trade name of phenobarbital. Luminal is a barbiturate. It is actually 5-ethyl 5-phenyl barbituric acid. That is, in the barbituric acid structure, if you are introducing one ethyl group and one phenyl group at the 5th position, this position is marked as the 5th position, we will get luminal. Luminal is chemically or marketed as phenobarbital. It is an excellent medicine against epilepsy. It is commonly used to treat seizures in young children and also used for epilepsy. Now, the present situation is highly pathetic. We all are in a state of pandemic situation, and the pandemic situation is ongoing, and we are in the pathetic position and pathetic attack from the coronavirus or COVID-19. Then what is the relevance in this discussion? That is, this pandemic situation can be cured by using antiviral drugs. Before entering into the details of antiviral drugs, we can move on to some scenario associated with the pandemic situation. It is an ongoing global pandemic since 2019, caused by severe acute respiratory syndrome coronavirus, or actually SARS-2 coronavirus second. This novel virus was first identified in Wuhan, China, as we all aware about the details, and how chemistry can support, how antiviral drugs can be developed to treat this severe pandemic situation, how chemistry helps us to support people suffering from COVID-19. In that situation, antiviral drug come into play. Viruses are difficult to kill, and hence developing of antiviral drug is a very challenging problem. Now we can enter into some details of the virus. As I mentioned, it is very difficult to kill. Any drug that kill a virus may also kill the cell. This is, for instance, I mentioned in the case of disinfectant. In the case of disinfectant, what is the difficulty in using a disinfectant? In using the disinfectant, it will kill both the host cell as well as the microorganism. But in that similar situation, antiviral drugs have several problems. The major problem is whenever you are using an antiviral drug to kill a particular virus, that antiviral drug will not kill virus selectively, but it also destruct or kill the host cells. Viral replication. How virus will undergo replication? A virus cannot replicate on its own nature because it must attach and enter a host cell first, because a virus cannot replicate itself. It then uses the host cell's energy. It actually acts as a parasite. That virus cannot replicate by its own capability. It first sticks on a host cell, then it penetrates into the cell and synthesize some protein by utilizing the energy of the host cell. That is the procedure of the viral replication. Therefore, this viral replication happens inside the cell. Therefore, whenever you are using a drug to kill the virus, that virus is situated inside the cell. Therefore, damage definitely goes to the host cell also. That's the trouble, that's the difficulty. Antiviral drugs. Viruses have no cell wall and are made up of nucleic acid and components. What are nucleic acids? They are the prosthetic group of nucleoproteins. There are two important nucleic acids. They are the DNA, deoxyribonucleic acid, and RNA, that is ribonucleic acid. And the viruses are made up of such nucleic acids, either RNA or DNA as their component. Viruses are obligate intracellular parasite. This I explained earlier, because these viruses penetrate into the cell, they utilize energy from the cell to replicate or to synthesize protein either as DNA or RNA. That is the nature of the virus. So, developing of antiviral drug is again a very difficult strategy. The problem, as I mentioned, that viral drug, antiviral drug will kill our cells as well as the viral cells together. Why there are few antiviral drugs? These are some reason due to very low availability of antiviral drugs. The antiviral drugs are minimum in number. The minimum number is because of these important points. Compounds interfering with virus growth can adversely affect the host cell. A compound must block virus replication completely. That is, whenever we are developing or synthesizing an antiviral drug, that antiviral drug must ensure complete virus replication prevention. That is, our antiviral drug must completely stop to 10% the viral replication. Suppose if you are using an antiviral drug and that antiviral drug will not completely stop the viral replication, then the same disorder, same viral infection may again occur after that drug usage. So, the selectivity of the drug is a very important problem. And moreover, the drug discovery is, antiviral discovery is highly expensive. Antiviral discovery is highly expensive. there are so many antiviral drugs now in use. Moving on to antiviral drugs that are commonly available. I already mentioned that there are minimum number of antiviral drugs, and we are now focusing on the common available antiviral drugs that we are still using. The most commonly used antiviral agents are derivatives of pyrimidine. What is pyrimidine? Pyrimidine is a molecule that is a heterocyclic compound. This is a heterocyclic compound, and this heterocyclic compound contains two nitrogen atoms. And this pyrimidine can have several derivatives, and most of the common antiviral drugs are derivatives of this parent molecule. How we can prepare derivatives? By introducing suitable groups, by making proper substitution here, or by introducing some groups on the nitrogen, etc. We can prepare so many derivatives. And the derivatives of pyrimidines are highly useful against virus, or most of the common antiviral drugs that we use are derivatives of pyrimidine are yes. Azodithymidine or AZT, the structure of which is shown here. This one is also a pyrimidine derivative. We can see the presence of the pyrimidine ring here. It is the derivative of the pyrimidine, and azodithymidine AZT is highly effective in preventing HIV/AIDS infection. So, it is an anti-HIV drug. It is a popular anti-HIV drug. This is the list of some very popular antiviral drugs. Acyclovir. Acyclovir is an antiviral drug used to treat the viral infection, that is herpes. Oseltamivir is effective against viral disorder influenza, or simply the flu. Tenofovir highly effectively prevent the hepatitis C. Combivir is a good medicine against HIV. Similar to AZT, Combivir is also an antiviral drug used to treat HIV. And finally, remdesivir, that is the effective medicine for COVID-19 attack. Regarding the structure of remdesivir. Remdesivir, during the present pandemic situation, World Health Organization and other agencies recommended remdesivir as authorized drug for emergency use in COVID-19 infection. It should be noted that the remdesivir is not effective against all the variants of all the structural variants of COVID-19 virus. We heard about the Delta virus, alpha modification, etc. This remdesivir is against only certain derivatives of virus. Whenever we are utilizing particular category of antiviral drug, it is against only structural variants of viruses. But after the prolonged usage of that antiviral drug, the virus as such may undergo some mutation and changes. That changes cannot be prevented by this common antiviral drug. That is also the hindrance associated with the discovery of antiviral drugs. Thus, by this discussion, we have focused on several kind of drugs, several kind of medicines, several common category of medicines that we use in our daily life, out of which we gave a focus on antipyretics, antibiotics, sulfa drugs, antiviral drugs, different category of drugs. Now we can move on some important points associated with drug discovery. it should be noted that most of the medicines are discovered accidentally. Nowadays, we are in need for several important antiviral drugs, and the scientists and researchers are focusing on getting new medicines to treat the viral infection or infection from several diseases, several lifestyle diseases, etc. But the practical attempt to get an effective medicine is hindered by several parameters. First one is its acute toxicity. Acute toxicity. A compound discovered has medicinal property, but whenever we are utilizing it in our body, it acts against our cells. That is, it is harmful to our body. So, toxicity offered by the medicine is a serious problem. Now, another important feature associated with drug is drug likeliness. Drug likeliness. For instance, paracetamol molecule is 4-acetamidophenol NHCOCH3. This structure has some antipyretic activity. So, whenever we are replacing this group by some modified functionalities, we are anticipating that this new molecule will have some medicinal activity. This molecule will have some medicinal activity. So, by using trial and error methods, we can replace the groups present in the structure by some new functional groups. We can check for the activity. That is, a basic structure has some drug likeliness. That drug likeliness can be tested by using computational chemistry methods, docking studies, quantitative structure activity relationship, quasar, etc. So, computational chemistry will assist us in drug discovery. Moreover, as the computational chemistry predictions are there, but all that predicted compound will not have a real activity. That is also another problem. So, computational chemistry helps us for the development of new drugs theoretically, and their activity should be tested by clinical and preclinical trials. Now, drug abuse. It is the intentional usage of drug when no medical or health reasons are existing. There are several drugs known as illegal drugs, drugs whose sale, use or purchase is outlawed by the government. That is known as illegal drugs. These are two important terms associated with the usage of the drugs. Finally, before stopping the present discussion, one interesting thing, have you noticed the term IP that appeared in medicine labels? For instance, suppose we are purchasing a paracetamol tablet from a medical shop. We can see a notation IP. Why this IP appeared in medicines, especially that sold in India? IP stands for Indian Pharmacopoeia. Indian Pharmacopoeia. Indian Pharmacopoeia Commission, IPC, is an autonomous institution under the Ministry of Health. It sets standards for all drugs that are manufactured, sold and consumed in our country. This is similar to several other pharmacopoeia. Similar to Indian Pharmacopoeia, there is well established pharmacopoeia in United States, that is United States Pharmacopoeia. In Britain also there is pharmacopoeia regulations, that is British Pharmacopoeia. Suppose this paracetamol is marketed in Britain, it is denoted as paracetamol BP. Paracetamol BP. In India, paracetamol IP. Even though both are paracetamols, they are having content and quality difference in these two kind of tablets. Similarly, if that paracetamol is marketed in United States of America, it is denoted as paracetamol USP. By this discussion, we are stopping the current presentation. Thank you very much for a very serious watching and listening. Thank you all.